Hello, welcome back. Finishing up 6.5 today. Gonna keep it pretty short. We just have one last set of examples to look at. So last time we looked at testing, so saying like, is this point a solution where you plug it in and you see if it's a true statement or if it's a false statement. Tells you if it's a solution. The second thing we did is we started to look at graphing, where we talked about like dash line versus solid line. And then we started with the basics. We started looking at problems like these where we did graphing, just special cases, x's and y's only, not a two variable equation. So what that leaves is our two variable equations. Okay. What you'll notice is the rules are the exact same as with special case equations. Okay. So, for example, we start by looking and saying, okay, is this a solid or a dashed line? Well, there's no underline, so this is going to be a dashed line. Okay. Similarly, the second step is the same, where we take our equation, negative 4x plus 5y, and we change it to an equation, not an inequality. Plus 5y equals negative 3. So now, just like we did before, we graph this. And this is going to be a little bit of a throwback because we have to remember how to graph equations. If you still have your cheat sheet, if you have your notes, a good thing to remember is one, identify what kind of or what form it's in. And it's not truly standard form, but it's similar to standard form. Okay? Which means I can find the x and y intercept really easy. If I want the x and y intercept, I just plug a 0 in for the opposite. So if I want to find the x intercept, I do negative 4x plus 5y. But when we want to do x and y intercept, we plug in 0 for the opposite. So it's going to be plus 5 times 0. So that just goes away. Equals negative, oh my gosh, if I could stop right clicking, 3. Okay. So, final step, divide by negative 4. Divide by negative 4. And the x-intercept equals 3/4. Okay, so this one's not a very clean one. Oh my gosh, I can't click on this. Okay, this one's not a very clean one, but that's okay. So my x-intercept is 3/4. Because the negatives cancel out. Sorry if you hear the crunching noise. As always, that's the dogs, and this one is chewing on a plastic bottle. Lily, stop. Okay, y-intercept, we're going to do the exact same thing. We plug in 0 for x, so this term goes away. Okay, so what we're left with is 5y. 5y equals negative 3. So we divide by 5, so y is going to equal negative 3/5. Now, this isn't how you're always going to graph. If you remember back to last chapter, if it's like slope-intercept form, you would just do the slope and the intercept. You would put the intercept down and then use the slope to find a second point. In this case, though, when it looks like standard form, we're going to find x and y intercept. So now I can actually plot those. So the x-intercept is 3/4. So it's going to be about here. The y-intercept is negative 3/5. So it's about here. So pretty tight line there. And then it is a dashed line. And if we remember, like using fractions, graphing them, we're not going to be perfect. That's okay because graphs are estimations. Okay, the exact answer is what you just did the work down below. That's where you find your exact answers. That's where you tell someone exactly where something goes. This is an estimation, so I went through my 2 points. I'm relatively in the right area. Last step, same as the last one. We have to find where the shading is, where all the solutions are. Therefore, I'm going to pick a test point. I like 0, 0. Okay, especially in a format like this, makes it really easy because 0 will cancel out that. The 0y will cancel out that. So what you end with is 0 is less than -3. Is that true? No, 0 is not less than -3. So I know my shading goes on the far side. Okay. Give me a second. I'll grab this one. All right. So, second example here, I want to change it up a little bit for you so we're not looking at two of the exact same problems. Okay, let's say we get something like this. No. So let's do something in slope-intercept form. So y equals, or sorry, we don't want to do equals. Let's go y is greater than or equal to 2x minus 3. So like I said, you want to be able to, you got to go back and use our old rules. So here we see that it's in a slope-intercept form, so that's how we're going to graph it. We should start first with, is it a solid dashed line? It's underlined, it's greater than or equal to. So that means I'm going to have a solid line. Okay? Now, moving on. Now we change it to equals. So y equals 2x minus 3. Okay, so now we go to graph it, and we say, all right, well, the y-intercept, my b value is -3, so that means the intercept's -3. The slope is +2, so up 2, right 1, up 2, right 1, and we have our line. So I would argue this one, it's actually easier if it's given to you in slope-intercept form or one of the, or basically not standard form, okay? Because then we just have to plug in the information we already know. Last step, test point. I'm going to use 0, 0 again. So 0 is greater than or equal to -3. When you plug in zeros for both, you get 0 is greater than or equal to -3. That is true. So I'm going to take this and shade that area because that's where the true statement was, showing that anything to this side of the line is my solution. The other thing I didn't explain before, but when you have a solid line, that also means anything on the line is part of the solution because it'll always give you an equal value. So it'll give you like 3 and 3. So 3 is greater than or equal to 3. Yes, that's true. Okay. So that's all we got to do. That's how we're going to graph. I gave you the steps last time. Those steps still hold for these examples, so make sure you're double checking those. Okay. Last thing I want you to do then, I want you to do this example 3 here. Oh, just kidding. And I asked you to try it last time, see if you could figure it out. So if you did it right, then you're good to go. If not, now I want you to attempt it. Okay, now I want you to attempt it. Otherwise, that's all I got for you today. Let me know if you got any questions. We'll come back with an assignment on Wednesday. Otherwise, enjoy the rest of your day. Make sure you are continuing to check Schoology for updated assignments. All right, have a good one.